A second part of our lesson on problem solving is, well, using a problem solving plan, well, to solve problems. So there's lots of different ways and lots of different models to solve problems, but let's take a look at this one here, a problem solving plan using models. And really, most of them are all going to be similar. The first thing we want to do when creating a problem solving plan is to make a verbal model. Basically, just put in words what our problem is. Ask yourself what you need to know, okay, and just write it down. Sometimes seeing it out in front of you will help you get an idea of how you want to go about solving it. After we write down our verbal model, then we want to label things. This is where we start changing it maybe into an algebra problem. If there's an unknown, we can assign a variable to it. Or we can start pulling numbers out of the problem and plugging them in certain places. Now after we start labeling things, now we can write our model. We can use formulas we know, like our simple interest formula or our distance formula, different things like that to help us solve the problem. Now once we have an algebraic model, now we can solve it. And isn't that our ultimate goal? When we have a problem, we want to figure it out, we want to solve it. So using algebra can help us do that. So once we solve and we get an answer, then maybe the most important part is to check our answer. We want to know, does our answer make sense? First of all, we want to know, does our answer make sense because, well, did we follow the steps for solving an algebraic model correctly? Basically, the steps for solving an equation. But the second part is maybe we solved it correctly, but our answer just isn't logical. Maybe our answer just isn't going to work for the problem that happened. So it's really important to check your answer. So again, one of the models we can use for problem solving is to write it in words. Then start labeling things. Start changing it into algebra. Write your model based on some formulas we already know. Solve it, and again, check. Make sure it makes sense. So let's look at an example. A jet pilot is flying from Los Angeles, California to Chicago, Illinois at a speed of 500 miles per hour. When the plane is 600 miles from Chicago, an air traffic controller tells the pilot that it'll be 2 hours before the plane can get clearance to land. The pilot knows that at its present altitude, the speed of the jet must be greater than 322 miles per hour or the jet will stall. At what speed will a jet have to fly to arrive in Chicago in 2 hours? So our goal here is to figure out which speed the jet's going to have to be traveling at. Okay? So again, we're wondering about the speed of the jet. Well, when we talk about speed, hopefully what comes to mind is our formula for speed. Distance equals speed, which we refer to as rate, times time. So again, this rate here, that's our speed. So we have this formula. Maybe we can use this formula to figure it out. So we have the speed of our jet that it's traveling, and we know that the speed that it's traveling times our time, that's going to be the total distance it has to cover before it gets to Chicago. Now I know that might be kind of hard to see. That's why we'll spend some time in class on, writing these models and everything. But I just want you to be aware that we can take the speed of our jet times however long it flies, and that's what our distance is going to be. Okay? So we kind of have a verbal model here. Now let's start labeling things. We don't know what the speed of the jet is. And when you don't know something, that's what a variable is for. Assign a variable to it. Now I put x here, but again, maybe you want to use s or something else. But we want to assign a variable to our unknown. Our time now, if you look, 2 hours before the plane hit Chicago, that's when it's going to be told. Or I'm sorry, 600 miles away, it's going to be told it's 2 hours before it can land. So the time that it's going to travel is 2 hours. And I just said it, but what is our distance we have left to Chicago? Well, 600. The distance to Chicago is 600 miles. Okay. Now I kind of combined, if you look at our model here, I kind of combined these two steps here. I labeled it, and I labeled it into our algebraic model. Again, just a little bit of a shortcut. But if you wanted to write it off to the side, speed equals x, that's fine. Time equals, that's no problem there. Okay, now we can solve. Okay, we're solving for x, so what number times 2 equals 600? Well, hopefully you would agree that x has to be 300, because 300 times 2 equals 600. Great, so we come up with 300, it's speed. Okay, so maybe we would say, oh, speed has to be miles per hour. However you'd like to write it. If you go to the last step here, though, we have to check our answer. So, does it make sense? Well, it's got 600 miles to go, and it's going to be 2 hours. Looking at our formula here, you know, I really do think it makes sense. Except we have a problem. Remember when I said when you check the reasonableness of your answer, you want to check first to make sure you got the problem right, but you also want to check to make sure your answer is logical. If you go back to the problem up here, it says the pilot knows that at its present altitude, the speed of the jet must be greater than 322 miles per hour or the jet will stall. That's kind of important. Must be greater than 322 miles per hour or the jet will stall. So, is it, even though I believe we did everything correctly here, is our answer reasonable? Okay. I would say not reasonable. I don't know about you guys, but I would not like to stall in an airplane just waiting to land. So, at this point, the pilot is going to have to take some other action. Maybe he would have to start circling or find some kind of holding pattern, but I don't think it would be a good idea for that jet to stall on the way to Chicago. So again, real life example, guys, of people, airplane pilots, who have to use math. And we will spend some time on this in class, just becoming familiar with setting up these models.